Alright, so we'll start exactly where we left off. We have got a blade sketch, we have got a hub. That's all great. um, let's go to this joint plane, right? First of all, let's just hide this blade sketch and just go to joint plane, and again define the transparency so that it's a bit easier to work with. Now we go again and we do something similar. We start sketching, we use an auxiliary line to define a point, and I just use the length parameter to define its height. I constrain it to be a vertical line using this. That's great. And then I continue on. Edit. I also draw a circle. Now I can define the radius of the circle. Let's make it 4.5. This should be all right. Great. So now we have a circle. If I just turn on the blade sketch, I have a blade as well. Look at that. That's good. I'll just turn off the joint plane to be off and rename this thing to joint sketch. Right. Okay, so what this joint is going to do is that it's going to connect our blade profile to the hub. How we're going to do that? Well, let's select extrude. Let's select this profile in the opposite direction. Let's go 20 so that it cuts into our hub. Let's make it 0. We will manually define the axis along which the extrude is going on, and we just say cut apply, and look at that, we have an extrude now. And what I will do now is that this plane, the blade plane, I will make it a bit farther so that the loft that I will create between the two can be a bit more smoother. So just turn it on. Where the blade plane head is at it. Let's make it 50. Let's make it away a little bit away. Let's it should be fine. Yeah. Right. So that's good. Now let's hide this plane and use the loft feature to connect use the loft feature to connect this sketch. So I'm not picking up the sketch. Let's just turn this extrusion off for a while, and then we go ahead and do that. This and this, and just like that we have a loft, and which goes from a circle to our blade profile. And we just turn on the early extrusion and we have a connection to our blade. Now we extend this blade even further. I'm just going to turn this loft off for a second, and then use the extrude, select this along with the direction. Let's make it 100, and let's make the base normal, select it manually, and that's it. Let's turn on the loft, and just like that we have a blade now, right? So we have gotten a blade. Let's name these things properly so that we know what we're dealing with. Let's rename this to hub solid extrude. Rename it to a joint solid extrude. Let's name this to rename joint solid loft, and let's rename this to blade solid blade. So we have gotten 4 solids and this entire configuration. Now what we will do is that we'll just beautify it a little bit. Let's apply a fillet here so it looks a bit better. 4 should be fine. All right, that's good. Now let's do some of the, so extrusion 1, extrusion 2, let's just go ahead and name this first, and then we will go ahead and create the parameterization, right? So let's rename it, and this will be blade solid extrude. Just to be sure, I named it properly, right? Solid blade. Let's rename it. All right, that's great. So we have and finally rename it to hub fillet. Fillet. Good. All right, so this is it, right? We have gotten a blade, but what now? Well, if I go here, there's something called parameters, right? Now what does parameter do? Let's first of all create some parameters. This is where the parametric modeling comes in. So let's say I want to control the hub radius, right? I want to be able to control the hub radius. We had selected the value of 20, we'll keep it that. I want to control the blade angle of attack. Let's keep it to, I don't know, 30 degrees. I want to control the length of the blade, so blade length I want to control, let's keep it to 100. So these are the parameters, these are the things that I want to control, say, and that's about it. These are the values that I want to control, plus one more thing, number of plates. So let's say number of plates is something that I want to be controllable, and let's start with 8 from the get-go. So I want an 8 plate. I want to be able to change the numbers, whatever. So what do we do now? Well, first of all, let's create, let's turn off the blade sketch 3 up sketch, so everything is a bit more clear. And let's select the solid parts, loft, and this thing, right? And create a single solid. So how do we do that? We use something called the fuse, right? And when I do that, just like that, I have now a single solid, and I will rename it to a solid plate, right? That's good. And rename it to solid plate, right? So this is a single thing now. Now what I can do is that I can go here and I can select angular copy. I want to copy it along z-axis, and instead of defining a number, what I can do is that I can choose the variable that I defined earlier. See, so now I can basically go to parameters, and I can do this, and it changes automatically. And what we will do now is that we will parameterize the other aspects of the thing. So I go to hub sketch, and what was that, hub radius? Yeah, that's it. This works. I forgot to add the prefix in all of these, but we will do that. Extrusion 1, right? This is the extrusion 1. So hub solid, name hub solid B, and just going to go ahead and just attach this to everyone, just to sort of be sure where am I. This will just naming things in a certain order. This will help in the later parts where you might be working with code and you don't know what is what, and having something like this, having a particular naming scheme can help you understand, okay, what are you dealing with, what are you touching, and what are you changing. So it's a good idea in general. F2 to rename it. Just go ahead and do that. Now instead of angular copy, let's name it blades Anyways, so this is it. Now let's go to the blade sketch and let's edit that too. And you know, so we had defined it to be 25, but now we can do this something like this, right? And now the blade's AOA can be defined parametrically, and blade length, we should have a blade solid extrude. Here it is. So this was it, and blade length, just like that. Now we can really play around with it. So if I really wanted a long blade, I can do something like this. If I wanted to change the angle of attack, I can do something like this. And if I wanted to increase the number of blades to say 10, I can do something like this. And without me actually modeling any part of it, this thing automatically gets generated. Now the beautiful part about this is that you can go into the file and you can say, hey, I export. What you can do is that you can dump study, and what dump study will do is that it will create a script. So let's call it parametric fan script, right? And let's save it. All right, so that's great. Now what has happened? Now let's go and see. If I go to CFD demo and Salome demo, we have this file called parametric fan script. What is this? Now if I go inside, right, parametric fan script, let's see. You see, all of the variables that we had defined as parameters are now directly available here. Now you know what, let's save this, and let's say, let's start a new project, completely new. Okay, completely new, nothing is there. Now what I will do is that I will simply go here, and what I will do is that I will load the script, and if I just do that, all right, something happened. Attribute second object is invalid. Okay, so I guess I didn't properly name parametric fan script.py. This should be fine. I guess I overextended it, so let's make it 200, and let's try to do it again. File load script, attribute second object field. Okay, so just going to figure this one out and get back to you guys. Alright, so I looked into it, and the issue was actually rather simple. So when I was going through the steps, I thought that I had saved the file, but I hadn't. So when the code was running, it was trying to figure out some feature that wasn't saved yet, but it had to create it. So it was a minor bug, not an issue, rather easily solved, And again, the fact that we gave sensible names to things came in handy, because you can look in the code and you can actually understand, okay, what is going on. You can see completely see that, okay, this is a step where we actually created the multiple blades and copied it around the hub. The issue was that the code wasn't able to find this particular object. In Python there's something called none type, so it was giving the error that, hey man, this thing doesn't exist, so how am I supposed to create it? And the reason was simple, that the information related to creating this thing wasn't stored, wasn't saved, because I hadn't pressed Control S. So that's it. Easy enough problem. I had thought that I had saved it, but apparently not. So like again, if you just go here and go to CFD demo, Salome demo, npmfs, let's wait a little bit, and you see this is the thing that gets executed. Something has happened definitely, but if I go to Salome, boom, just like that, this thing is loaded, right? And now you can understand the sort of power that you now have, right? So I can go here, right, and let's change a few things around. Let's So I've already increased the blade length to 400. Let's make that, let's reduce that to say something like 50. Blade angle of A, let's make it 20. Let's make the hub radius to be, I don't know, 25. Number of blades to be 8, and I've changed things around, right? And I will just save this file, and then when I load the script again, we have got an cute little fan, ready to go. So this is it. I hope you can understand, the sort of power that you now have. So when you're now, what you can do is that instead of going ahead and modeling something, you can just use this script, execute the script, right? You can define these parameters as variables, and this is just Python, so you can import it from some other files. You can import design variables, right? And things like hub radius and stuff can be imported from there. Hub radius can be, wait a second. So if you had imported something like import design variables, right, you can say something like hub radius equals to whatever design okay, design variables dot hub radii or hub radius, and you can using this basically you can completely automate your process of a CFD by you can have a code here which basically checks for whatever the results you want to check, right? You want to check some results from the output of a solver, from the output of a solver, right? And then you can define some sort of function that will change these design parameters in order to achieve whatever kind of output you are looking for. So maybe you want more thrust, so you're like, all right, let's see what happens if we increase the angle of attack by say +5, and let's do it in a loop, right? We change the angle of attack by 5 degrees in every simulation and see which gives us the best result, and thus you can sort of automate the process of optimizations, and you can store the results, and you can say to Python, hey, whenever you get the results closest to what you want, stop the simulations and send the results. And that's how this thing will be this is how you will connect these various aspects of CFD pipeline. For now we will stop here, but later on we will actually go through that detailed simulation part and actually simulate a fan and stuff and see how that will actually work out. Thank you.